heart went.
Let's solve for sample problem 2.1. The problem says, a resistor in series with an 8 ohms. So, let's represent yung resistor na binanggit. A resistor. We do not know this resistance. In series. This is connected in series with an 8 ohm resistor. This one is 8 ohms. Absorbs 100 watts. So, yung subject natin dito, yung unknown resistor daw, when it is connected to an 8 ohm resistor, can absorb 100 watts of power, which means, meron tayong 100 watt power on this unknown resistance. When these two are connected, when the two are connected across a 60 volt line, ibig sabihin, you have a source that gives you 60 volts in voltage. Find the unknown resistance R. So, itong nawawala pala nating resistor, pinangalanan na siya ng problem as R. When the two resistances in series are connected to the 60 volt line, the value of I total will flow through the circuit. And we know that this I total is also the same current that flows through the unknown resistance R and through the 8 ohm resistor. So, let's say this is I. So, to solve this problem, since you are already given power of this resistance as 100 watts, that means you get P equivalent to, let's say we use I squared R. Okay. So, this is power in the unknown resistance. I is the current that flows through the unknown resistance, and R is the resistance of resistor R. First and foremost, you already have 100 watts. We do not have this value of resistance. Tapos wala din tayong value ng current. But, by principle of series, we know that the total current is simply equivalent also to the current that flows through each resistance. So, let's say that would be equivalent to I then, the current that flows through R. To get I total, by Ohm's law, we know that that's voltage, total voltage, over total resistance. So, it would appear that I total is simply equivalent to the total impressed voltage, which is 60 volts, divided by the total resistance of the circuit if it is in series. Diba? We know that RT for this circuit is simply equivalent to the summation of all resistances in series, and that would be R plus 8 ohms. So, for RT, that would be R plus 8, the quantity in ohms. If we try to substitute this value here, power which is 100 watts, diba? That would be equivalent to I, the value of I is equivalent to I total, and this is our quantity for I total. It's a function in terms of R. That would be 60 all over R plus 8. So, we have here I squared, so we take the square of this quantity. Okay, multiplied by R. Okay, so by laws on exponents, we know that this is 100 watts equal to 60 squared over R plus 8 squared, the quantity multiplied by R. I'm going to cross multiply this two. That would give me R plus 8 squared equal to 60 squared, that's 3,600, divided by 100 watts multiplied by R. To solve this, we're going to expand the left side of the equation, and that would give you R squared plus 16R plus 64 equal to 3,600 divided 100 would be 36R. And if I transpose this to the left side, you'll get R squared minus 20R plus 64 equal to 0. By factoring, you'll get R. You'll get two answers for R, since this is a quadratic equation. And that would be 16, R minus 16, and R minus 4. Which results as the value of resistance R may either be 16 ohms or it could be 4 ohms. You can check your answer using your calculator. For quadratic equation, we use mode 5 and we use this one, mode 5-3. Make sure that when you use quadratic solutions on your calculator, the equation is equated to 0 and it is arranged in decreasing order. So, we start with the highest ordered term hanggang sa mawala siya. So, we have coefficient of the squared term, that would be 1 equals, this is negative 20. So, you type negative 20. And then we have 64 for the constant. Equals, press equals again. That would give you the first root, which is 16. That's our first answer. And 4. That's our second answer. Therefore, the value of resistance R may either be 16 ohms or 4 ohms. Both of them will satisfy the condition that if you connect the 16 ohm resistor here, it will produce 100 watt of, or it will absorb 100 watt of power, even if you substitute the resistance 4 ohms here. If you want, we can test this. So for proving, if the resistance R is equivalent to 16 ohms, we will be able to get a total resistance, the sum of the two. And that would be 16 plus 8 ohms. You'll get 24 ohms in total. Okay. So if you have a total resistance of 24 ohms, we can solve for the total current that will flow through the circuit. And that would be Vt over total R. That's equal to 60 over 24. And that would be 2.5 amperes. So, if the total current is 2.5 amperes, it only means that the current that will flow through resistance R will also be 2.5 amperes. Thus, this is equivalent to I. If you want to solve for the power that will flow through this resistance, we can use I squared R, the current that will flow through the resistor, which is 2.5 amperes, quantity squared, multiplied by the value of resistance R, and we let that as 16. And it will show you that it will absorb 100 watts of power. If instead we use 4 ohms for the value of resistance R, we can get the total resistance. So if this is 4 ohms, we add that to 8. We'll get a total of 12 ohms for this circuit. To get the total current that flows, that would be again Vt over RT. Vt is 60 volts divided by 12 ohms. You'll get 5 ampere as a current. So as you can see, the value of the current that flows through the circuit changes whenever the value of the resistance also changes. So if the total current is 5 amperes, that will be the same current that will flow through R. But since R has a new value, which is 4 ohms, okay, if we solve for the power that will flow through R, using I squared R ulit, the current that flows through R is 5 amperes. Square that, multiply that by the value of the resistor R, which is 4. That will still give us 100 watts. So for this problem, you have two answers. It could be 16 ohms, could be 4 ohms. Okay, let's solve for problem 2.3. The problem reads, in a series circuit, so may series circuit tayo, a current flows from the positive terminal of a 180 volt source through two resistors. So yung series circuit natin has a constant voltage source of 180 volts. May current daw na magfo-flow from the positive terminal of this source. So you have an I total here. Papunta sa dalawang resistor. So binanggit, series connection daw yan. Okay. One of which has 30 ohms. Yung isa daw dito has 30 ohms resistance. and the other of which, ito daw, has 45 volts across it. So, meron daw tong voltage drop na 45 volts. If you're going to analyze how the phrase is mentioned, 45 volts across it, sa tapat. Diba? May 45 volts daw sa tapat ng resistor na to. And that is because, for us to be able to know that this has 45 volts of drop, magkakabit tayo ng voltmeter dito. And we know that voltmeter, base sa plates na ginawa nyo before, we know that voltmeters should be connected to the component in parallel. Ibig sabihin, pag nagkabit tayo dito ng voltmeter, so magkakabit tayo ng wire dito, you'll have a voltage reading here. And according to the problem, that's 45 volts. Okay, that would be the voltage drop of this resistance. So we know that voltmeters must be connected in parallel because it will follow principle of parallel circuit, and only if they are connected in parallel will the voltages be equal. Diba? Pag nakakabit siya ng parallel, dun lang magiging equal yung voltage niya. So ibig sabihin, yung mariread ng voltmeter mo, kung anong voltage yung nandito, since they are connected in parallel. Ngayon, kung current naman yung i-measure natin, dapat si ammeter, yung meter na ginagamit natin to measure current, should be connected in series. Ibig sabihin, kung magkakabit ka or maglalagay ka ng ammeter dito, dapat andito siya. Naka-series dapat si ammeter mo dyan. Or, ganito, mali yan. Yan, yung ammeter natin. Okay, because it is only in series circuit where the current readings are equal. So, meron tayong 45 volts voltage drop here. The question for us is, find the current and the unknown resistance. So, when we say find the current, hindi na kailangang i-specify pa ni problem kung sino bang current yung hinahanap natin. Kay 30 ohm current ba? Or dito ba sa resistor na to na current? Or yung total current pa? Because if it is series, alam natin pare-parehas yung value niyan. So, let's say, IT na lang. Find the current and the unknown resistance. Ito daw. Okay, so, for the unknown resistance, let's say this is R ulit. So, find R. Okay. So, to solve this problem, basically what you have are VT and the voltage drop here. Diba, if it is series, we know that the total applied voltage will simply be equivalent to the voltage drop in the first resistor, let's say that's V1, plus the voltage drop on the second resistor connected in series, and that would be V2. And from here, we know that V2 is already 45 volts, VT is 180. So if you substitute that would be 180 volts equal to V1, the voltage across the 30 ohm resistance, plus V2, which is 45 volts. So from here, pwede na nating makuha yung voltage drop dito sa kabilang resistor na to, and that would be 180 volts minus 45 volts, and that would give you V1 equal to 135 volts. So if V1 is 135 volts, if you're going to look at this resistor, dalawa na yung parameters na meron siya. Meron na siyang voltage drop, meron din siyang resistor rating. So ibig sabihin, pwede ko nang kuhanin yung current na nagpa-flow dito. Say that's I1. Diba? That I1 would be equivalent to V1 over R1. And yes, we already have V1, that's 135 volts, divided by R1, which is 30 ohms. So to simplify that, you'll get the current that flows through this as 4.5 amperes. And that would be our answer for I total, or find the current. That would be 4.5. Since equal naman sila. This is also IT. Okay. For the unknown resistance naman, once you have the current that flows through the circuit, may current na din dito since equal naman yan. So if you already have the current that flows through here, you already have the voltage drop across that resistor, we can already solve for the unknown resistance R. And this time, that would be V over I naman. At V2 over I2. So V2 is 45 volts. Divide that by the current that flows through this resistor, which is also 4.5 amperes. And it will result to an unknown value, na known na ngayon, which is 10 ohms. So, ito yung sagot natin. So remember, it's very important that when you have a worded problem, you're able to draw the circuit diagram correctly, understand the connection, or understand the principle of the connection prevailing in the problem. And then of course, do not forget the laws that govern that particular connection. Okay, so for problem 2.5, question is, what is the maximum voltage that can be applied across the series combination of a 150 ohm 2 watt resistor? So, meron tayong series combination ng resistor rated at 150 ohms. Power rating of 2 watts. Let's say this is P1 para ito ay R1. This is connected in series to a 100 ohm. This is our second resistor. That's 100 ohms. Rated 1 watt resistor. So yung capacity rating nito, or power capacity, is 1 watt. Without exceeding the power rating of either resistor. So ano daw yung voltage supply na pwede nating ikabit dito in series? So, lagay tayo ng voltage. Okay. What is the maximum amount of VT? Maximum total voltage that we can apply to the circuit such that hindi lalampas sa power capacity yung mga components natin. Okay. So, if we are looking for the total voltage, that's VT. Ibig sabihin, I have to use IR, VIR, diba? That would be I total, R total. Okay. For me to get the total voltage that would be applied, that would be IT times RT. Going back to the circuit, you already have rating of resistance 1 and resistance 2, which means you can solve for RT already. That would be the sum of the two resistances in series. Therefore, you have RT equal to 250 ohms. So, you already have RT. Question here is, what should be the total current? Ano dapat yung current ang magfo-flow? What should be IT in this circuit para, what is the maximum I total in this circuit para hindi lumagpas sa power rating ang bawat resistor? So, para makuha natin yan, ang gawin natin, since you already have power rating of each and resistances, kunin natin. Ano yung current na pwedeng dumaan sa mga ito? Just so they can hit the 2 watt power and for resistor to the 1 watt rating. Okay. So, if power is equivalent to I squared R, since ang hinahanap natin dito, kuryente, di ba? Kailangan malaman ko ano ba yung value ni I1, ano yung capacity, ano ba yung capacity ni I2? Ano ba yung current capacity ni resistance 2? Para malaman natin, alin sa dalawang ito i-consider natin just so hindi lumampas sa power rating yung isa sa kanila. Kasi obviously, with different power ratings, magkaiba sila ng kakayanan. Obviously ito, since mas malaki resistance niya, diba, ang tendency, mas malaki yung voltage drop dito. And if you have larger voltage drop here, pag in-apply mo siya dito sa kabilang resistor, yung mas malaking voltage drop na to will cause greater current. So, if there's greater current, may tendency lumampas si P2 sa 1 watt. And hindi pwede yun according to the requirement of the problem. So, ang gagawin natin, kuhanin natin yung current ng bawat isang ito. To solve for current, that would be, I have to divide both sides by R. So, you get P over R. Diba? P over R equal to squared of I. So, naka-square yan. Naka-square yan. This is I squared. To get I lamang, we get the square root of each side. So, pag in-square root ko to I na lang yun, no? That would be square root of PR. This will be our formula. So, if I'm solving for I sub 1, this is equivalent to the square root of P1 over R1. And that would be the square root of what's P1? 2 watts divided by R1, which is 150 ohms. So, if you press that in your calculator, you'll get I1 equivalent to 0.1 0.1155 amperes. Okay, we'll do the same for resistor 2. That would be the square root of P2 over R2. And that would be the square root of 1 watt over 100 ohms. So that's 1 over 10. Kaya siya ay 0.1 ampere. So if you're going to notice, yung current capacity na resistor 1 is higher than the current capacity of resistor 2. So ibig sabihin, ito yung limit mo. 'Di ba? Kasi kapag in-apply mo yung 0.1155 ampere dun sa resistor 2, obviously lalampas na yan ng 1 watt rating niya. Hindi kakayanin ng component mo. So ibig sabihin, dito lang tayo. 'Di ba? For our appliances at home or for loads that we have, it's very important that we keep the performance at their rating. So, kung hindi kakayanin ni resistor 2 yung 0.1155 amperes, dito tayo. We have to limit the circuit with 0.1 ampere current. Okay, why? Because if it is anything above 0.1, lagi na siyang lampas sa power rating ni resistor 2. Eh, ito naman, since ang maximum niya ay 0.1155, kaya niya hanggang 0.1155 amperes. Ibig sabihin, kakayanin niya rin kahit lesser than 0.1155 amperes. So, kung i-apply natin to dito, diba, you'll get a smaller power output or absorbed power. And walang problema kasi ang requirement lang naman sa atin ng problem, wala daw lalampas. I mean, what should be the applied voltage so that walang lalampas sa power rating ng bawat isang ito. Thus, we limit the current to 0.1 ampere. Now, if we adapt 0.1 ampere here, I1 will also use 0.1 amperes in series. Therefore, IT is already 0.1 ampere. So, if this is equal to IT also, and we try to substitute that here, you will get 0.1 ampere for the total current multiplied by the total resistance of 250 ohms. The applied voltage would be 25 volts. And this will be our maximum applied voltage because we are already using the maximum, the possible maximum current that we can apply to the circuit, and that's 0.1 ampere. Okay, let's move on to problem 2.7. To determine the resistances of three resistors A, B, and C, the following procedure is followed. A and B are connected in series. A and B are connected in series. And an EMF of 21 volts is impressed for a current of 1 ampere. Okay. So si A at B daw kinonect ng series, tapos ikinabit sa 21 volt source. Let's see, ganyan itsura niyan. This is 21 volts for a current of 1 ampere. So 21 volts daw in-apply dito para makapag-produce siya ng 1 ampere current through the circuit. Okay. Next, B and C are connected in series. Si B at si C naman daw. B, C are connected in series. And an EMF of 27 volts is impressed for the same adjusted current. So, para naman makaproduce tayo ng 1 ampere sa circuit na to, para 1 ampere daw yung kuryente dito, ang impressed voltage daw nito dapat 27 volts. And lastly, C and A are connected in series. C and A. Pwede ko namang unahin si A, diba? To produce 1 ampere current then, according to the problem, yung source naman na ikakabit natin dito ay 24 volts. What are the ohmic values of A, B, and C? Ayun. What is A, what is B, and what is C? Looking at circuit number 1, we know that V total is simply equivalent to I total, R total, correct? Okay, you already have here V total, you are given I total. Diba? So if VT and IT are given, you will have an expression for RT. or you will have an equation in terms of the resistors. Try natin substitute. So, VT is 21 volts. That would be equivalent to the total current 1 ampere. And for me to get the total resistance of that circuit, this is simply sum of A and B. Diba? If we divide both sides by 1 ampere, 21 pa din to. Lalabas you have an equation that is A plus B equal to 21 ohms na. Kasi resistance to eh. Voltage divide current is resistance. So you will have this as an equation provided by the first circuit. Let's say this is equation 1. You will notice a similar pattern for both circuits 2 and circuits 3 since they all have 1 ampere current. So, parang mayayari dito. Pag nag-VT, IT, RT ka dito, ang mangyayari lang dyan, you get 27 volts equal to, anong I total niya? 1 ampere times, anong total resistance ng circuit na to? That's B plus C. In turn, you'll be able to create B plus C, diba, i-divide natin yun doon, equal to 27 ohms naman. This is equation number 2. And then for the third circuit, ganun ulit. You have total voltage, that's 24 volts, equals total current, that's 1 ampere, multiplied by the total resistance, which is A and C. Therefore, you get the third equation, A plus C equal to 24 ohms. This is equation 3. So, as you can see, this will fit simultaneously solving linear equations. Okay, so balik tayo dun kay algebra. Let me erase some of this and rewrite the circuit. Rewrite the equations. So you have A plus B equal to 21. You have B plus C equal to 27. And then you have A plus C equal to 24. So, by simultaneously solving the equations, diba, without using your calculator, we can add these 3 equations, and that will give us A plus B plus B plus C plus A plus C. So, yung meron kang dalawang A plus dalawang B plus dalawang C. Or, could be 2 times A plus B plus C, right? Kapag finactor out ko yung 2. 2A plus 2B plus 2C. If you factor out 2, that would be 2 times A plus B plus C. Equals, you have 21 plus 27 plus 24. That gives us 72. 72. We divide both sides by 2. You'll get an equation of A plus B plus C. That's equivalent to 36 ohms. So, upon knowing that the sum of the 3 equations is 36, pwede mo nang gamitin bawat isang ito in this equation para makuha mo si A, si B, and si C. Okay, what do I mean by that? Okay, if A plus B is 21, so ito daw. If A plus B is 21, plus C, diba? 21 plus C equal to 36. Makukuha na natin si C. And C will be 36 minus 21. And that would be 15 ohms. Next. If A plus B plus C equals 36 and B plus C is 27, ito daw, B plus C is 27, that will result to A plus B plus C is 27 equal to 36 ohms. You'll be able to solve for A. A will be equivalent to 36 minus 27. That will give us 9 ohms. Next. If A plus B plus C is 36 and A plus C is 24, so, si A plus C daw ay 24. Anong tira? Plus B equal to 36. We'll get B equal to 12 ohms. And that gives you the value of the 3 unknown resistances. If you do not want the conventional, syempre kailangan ko lang ipakita yung conventional. At baka nangangalawang na tayo dyan, diba? Okay, you can use your calculator for that. Walang problema yun sa akin. So, let's go back to this 3 equations. Ano? For 3 unknowns, for simultaneous equation, we press mode 5. For 2 equations, we press 1. For 3 equations, we press 2. So, since this is 3 equations, we press 2. And then we substitute. So my arrangement will be as follows. Ito na, A, B, and C. So for first equation, you have A plus B equals the constant 21. So A is 1. Coefficient of A is 1. Coefficient of B is 1 also. I do not have C in this equation, so that would be 0. Equal to, the right side of the equation should be your constant. That's 21. Equals. Second equation is B plus C equal to 27. I do not have an A in this equation, so that would be 0. And then, the coefficient of B is 1. The coefficient of C is 1 also. The constant should be in the right side of the equation. That's 27. Okay, for my last equation, I have 1 coefficient of A. I have 0 B. I do not have B. And then I have 1 C. And the constant on the right side is 24. Okay, press equals. Your answer would be as follows as A, B, and C. So A is 9 ohms, yes. B is 12 ohms, correct. And C is 15 ohms. So that gives you sample problem 2.7.